Hey everyone, welcome back to another session with OneClass. Today we're going to be answering some physics questions. My name is Bassam and I'm an engineering graduate. And the physics questions that we'll be answering today will be at the high school and the preliminary university level. Okay, so let's get started over here. Okay, so the first question here that we're asked is how do the speeds v0, v1, and v2 at times t0, t1, and t2 compare? Okay, just give me a second here. Let me just check something real quick. Alright, so we're looking at 5 options and we're trying to figure out which option is the correct answer. So they have a plot down here for us. So looking over here, so we have v0 at the initial of the projectile. So we can see right here the projectile follows this kind of motion, a parabola, and we have v1 on top, and you can see that this vector is a little smaller than this vector. And then v2 over here we have the vector pointing downward, and we can see this is kind of equivalent to this vector. Okay, so one thing to note for parabolas or anything that's going upwards and then downwards, there is a conservation of speed based mainly because of conservation of energy. So at this point when it's initially thrown, all the energy is in the kinetic energy form, and as it goes up, this kinetic energy is converted into potential energy, and then the speed diminishes, and then as it goes down, the speed accelerates down, and then the potential energy is converted back to the kinetic energy. And we can see here the speed in point 1 is only in the x direction because there's no acceleration in the x and y. It's mostly in the of upward and downward, so in the y-axis, because it's due to the force of gravity. So here we'll look at option A. So here it's telling us v0. So in option A, v0 equals v1 equals v2, which is greater than 0. So all speeds are greater than 0, so that's true. However, we can see that not all the speeds are equal, so we can cross out option A. For option B, v0 equals v2, so speed v0 over here, and then we have speed v2 over here. So that is true with respect to magnitude, but not with respect to direction. And then v1 is less than v0 and v2. So here we can say that this is correct. And since the question is asking for speed, not velocity, speed is measured in magnitude, not in direction. So speed is a magnitude kind of quantity, versus velocity is a magnitude and direction quantity. So we'll mark B correct for now, but let's just double check the rest of the answers. So for C we have v0. So actually I made a mistake. I missed the equal sign. So this is the correct answer over here because it's a greater than 0. v1 is greater than 0 and not equal to 0. So we actually got to say that answer B is incorrect, and answer C, because we have all the speeds are greater than 0, but v1 is less than v0 and v2, and v0 and v2 are equivalent, as we can see in the diagram. So we'll say C is correct. Let's double check D. So for D, we have v0 is greater than v1 is greater than v2 is greater than 0, so we can say that's not true because v0 equals v2, so D is incorrect. And then finally for E, v0 is greater than v2, which is greater than v1. So they kind of rearranged it here, and this doesn't make any sense because we know v1 is not equal to 0, so we can kind of cancel B and E right away, and then looking at the rest, we know that v0 is equal to v2, and then we can see that this one is the correct answer. So we know this is wrong. So we have C is the correct answer. So we'll go scroll down, see at the attempted solution. So from the given diagram, V0 and V2 are same. So we have V0 is equal to V2 is greater than V1 is greater than 0. And this is option C. So the student selected the correct answer. So this is the case of projectile. In a projectile, there are various factors that can affect maximum projectile range, and it follows a parabola. When the projectile is at the highest point of the velocity, at top position is 0, and it increases again when it falls from the top. The horizontal and vertical motion of projectile are independent of each other. So we can see that the horizontal, so in the y-axis, and the horizontal in the x-axis and the vertical in the y-axis, these motions are independent. So here, this answer is correct. Great job. Okay, so we'll mark this solution as correct.